So, hello everyone. Morning or good evening. Open the CATIA. Your workbench will look like this. Okay. So, so to cover everything in a single class is a difficult part. Okay, but I'll try to cover up what all the things that are required to understand before learning the CATIA or even any other CAD softwares. Okay. So basically, KDI is where you can able to create your 3D models like by creating 3D models, and also we can also optimize the models that are created. Okay, and basically your KTIA is nothing but computer-aided three-dimensional interface application. Okay, or interactive application is also called as, right? So this not only this, but also the other softwares like SolidWorks, AutoCAD, NX, all these, all these CAD software, all these are called as CAD software, which is meant by computer-aided designing softwares, where we can able to create or model any part or product as per our requirement by using the features which available in the softwares. Okay. Now there are different workbenches in the CATIA, right? So, like for example, you can able to create a solid body. Solid body. Let's divide them into types. Okay, with the help of the thickness. Okay. So, above 6 mm thickness metal body is considered as a solid body, right? And between zero point 0.3 to 6 mm material is considered as sheet metal body. Okay. And also manufacturing them also matters. Like how do we manufacture those thickened bodies also matters. Okay. Like if you use bending or or stamping methods, then it is considered as sheet metal. You use EDMs or CNC machines, then it is considered as solid body. Okay. Below zero point 0.3 mm is considered as foil. Okay, below zero point 0.3 mm to zero point 0.1 mm is considered as foil, and zero point 0 mm is considered as a surface body. Not surface body, it's a surface. Okay. So depending upon these three workbenches, surface, sheet metal, and solid body, we have three different workbenches in the design. Okay. One is your part design, which is solid modeling. Okay. And the other one over here is generative sheet metal or sheet metal design. Okay. Or generative sheet metal design. All this comes under sheet metal. Okay. And the other one is wireframe. Okay. Wireframe and surface design. Mostly these three are the important concepts, or are the important workbenches that we need to know as a beginner. Later, we can able to see how do we use mold tool designing, and also how do we use functional molding part. All those things we can able to study once we are thorough with these things. Okay, and part modeling, sheet metal, and surface designing. Okay. Now, with respect to these three, now basically these three are modeling workbenches. Okay. And the other two workbenches are, one is drafting, which is also called as drawing, where we'll be converting that 3D modeled part into a 2D model part or 2D model representation in the drafting. Okay. And in the assembly, where we'll be assembling all these parts which we have made in all these workbenches. by using assembly design workbench, and then we'll assemble them to check the interference between each and individual parts and to check the fit, how the fit is going to happen. Okay, all those things, and also we can able to study DMU also, kinematic analysis. Okay, so you will be having over here DMU kinematic. Okay, that means you can give a motor to a running part, like if you are creating a engine. Okay, so for that engine, you can give a power to the flywheel and you can see how the stroke is happening. Okay, that is considered as DMU kinematics. It's an example. All right, like that, there are multiple parts which are meant to be moved. Okay, so we can able to check the movement also, how it is going to happen and what is the behavior of the product by using the DMU. Okay, not only this is these concepts which I told you, or these workbenches currently which I discussed, are just a bit of a CATIA. Okay, so there are so much other than these concepts. There are so many things that we can able to do. Like for example, you can do electrical harnessing also as well. Okay, and you can able to check the machining also as well. Over here, you can see lathe machining. Okay, everything you can able to do. CNC manufacturing, NC manufacturing also you can do. That means you can able to, before bringing the part into a real time, you can able to perform any simulations or any manufacturing processes on the particular part in the software, and then you can optimize the design as per the requirement, and you can able to select the proper material according to the results which you got from the simulations. Okay, analysis simulation you can see over here. So that's why this software is considered as an high-end software. Okay, so all the three workbenches, major three workbenches like CAD, CAM, and CAE are available in this software. Okay, computer aided designing, computer aided manufacturing, computer aided engineering. Okay, so you can perform all these studies before bringing the prototype into the real time, or before bringing the product into the real time. Okay, now we understood the application of the CATIA, like what all the workbenches are there, and how we can, now we will be seeing how we can able to use that, use those applications or those workbenches. Okay, so we know that part designing means like creating a solid model. For example, you can able to create any kind of models. Like these are just an examples. Okay, so such kind of parts you can able to generate n number of parts in the model, in the surface, or in the part modeling, or in the sheet metal. Okay, that depends upon. Okay, so you can see over here, if the part is a bit complicated part where you need to use all the curves and all to create that part. For example, this part is having more curves rather than a straight body. Okay, so at this time you need to use surface designing. Okay, once you understand the workbenches, then it will be very simple for you to select the proper workbench to create a particular part. Okay. Now, if you see this part is a simple part, so these parts can be created by using solid modeling. Okay, like that, this one is a bit different part. So it can be created by using sheet metal, because you can see 3.5 thickness material is there, and all this part, and to manufacture this part, it should undergo stamping, okay, and cutting, laser cutting, and then punching, all those things. This can be done by using punching. Okay, if you have a die, okay, you can able to simply punch it over there, and at a time you can bring all the holes at a time, right? So for that, you need to know the manufacturing processes first. Okay. So like that, there are multiple parts can be generated by using this CATIA software. So to create that part, for example, to create any single part, let's discuss a single part over here. A simple part. I'll be discussing a simple part. Okay. For example, this one. Okay, this one. You need to create this part over here. Okay. So for this one, what we need to know first, any from you're creating any model means you need to understand if the model's drawing is given, you need to understand how to read the drawing first. Okay. So if you understand how to read the drawing, then it will be very simple for you to model the drawing. Okay. And also, once after reading the drawing, you need to, if you are creating any part in a solid, if you are creating any part in a CATIA or in any other software, for example, like SolidWorks, etc., etc. Okay. So first you need to know the features. Okay. If I go to part design, click on OK. See, there are multiple features over here, multiple tabs over here. In the multiple tabs, there are multiple features over here. Everywhere you can see all these are features. Okay, so that's why this CATIA, SolidWorks, and XCAD, all those softwares are considered as feature-based softwares. Okay, AutoCAD is where it is basically both. It can be command based and also it can be feature based. Okay, because your features also will be visible and you can able to mostly will be using command based only in the AutoCAD. Rarely will be using features because not all the features will be displayed. Okay, some features needs to be searched from the command prompt. Okay, so here also we can able to search the features. So over here you can search the feature, whatever the feature you want. But mostly here all the features will be appeared over here. If not, you can able to select whatever the features that are missing. Okay. So CATIA software and its user interface has one advantage over here. Typically, all the softwares like SolidWorks, NXCAD, Pro E, all these things, feature tabs will be fixed. Okay. So except in this CATIA, you can able to place wherever the tabs you need, and that makes your work very simple. Okay. Because if I am going to create any part and I want to select the feature, okay, rather than I am going all the way top over here and selecting it and coming back and doing my modification, I can simply bring my required tab over here and I can do the modifications whatever I want. Okay. So it will be a user-friendly software when compared to the remaining other softwares. Okay. And now to create this part, as I said, we need to understand how to read the model. Read the model. Okay. So let's say we understood how to read the model. Okay. Now the next step is to understand how the features are functioned in the software. Because what we are doing, let's say this is an image in your mind. Okay. You want to convert this image into a proper model. Okay. This is an idea in your mind. Okay. You want to show it to some other person. So at that time, you need to have a medium, right? So that medium is your software. Okay. So earlier, that medium will be a pen and paper, right? So over there, what we'll do, we will be sketching it, okay, by using pen and paper and scales and pencils and erasers. We will be sketching everything, right? So so those pen, paper, eraser, sharpener, all those are tools, right? So here, these are considered as your tools or features. Okay. Now, now this is a 3D model, right? So to create this 3D model, you need to have a 2D sketch. Okay. So currently, once we select the part design and enter into the workbench, part designing workbench, these features which you are going to see over here are your 3D modeling features. That means if you have a 2D sketch, by using these features, you can convert that 2D sketch into a 3D model. Okay. But before that, we need to have a 2D sketch, right? So to have a 2D sketch, we need to enter into a 2D sketching workbench. Okay. So first of all, let me show you what all these things. Over here, left side corner top, this is called as specifications tree or design tree that depends upon the software. Okay. So here you can consider this as a design tree. Okay, and these are called as your tabs, different tabs. Inside the tabs, you have features. Okay, and this is also a toolbar. This is also a toolbar. Okay, these are also on the right, on the top, on the bottom. All these are considered as your toolbars. Okay. Now, if any tabs are missing, these are tabs, right? If any tabs are missing, you can just right click on the toolbar. Okay. And you can select whatever the tabs that are missing. Then this is the compass. These are the default planes. Okay. Default planes. What is default planes? Basically, as I said, in olden days, we will be having a paper, right? So these default planes will act as a paper. Okay. Now this is a file menu, okay, where you can able to edit or create a new file, okay, or insert any tools, anything that can be done from here. Now this design tree will be basically saving your history of your part, which you are going to create right now, okay, because to re-edit that part, we need to have anything, something, right? So that where you can able to save all the history of your part. Okay. So now we understood everything. Let's go into the 2D sketching environment. Okay. So to enter into the 2D sketching environment, we need to select the sketcher. Okay. And then select the plane. Sketcher is basically, you can see over here, you can see the image, how it is looking. It looks like a pen or a pencil and a paper, right? So this basically sketch command or sketch feature acts as a pencil. Okay, and this plane acts as your paper. You can select whatever the plane you want currently. I'll be selecting YZ plane. Okay. Once after entering into the environment, sketcher environment, again you can see different types of tabs are appeared over here. Okay, so here you can use these profile tools to create any shape that is required for you, like circle or a rectangle, anything that is required for you. Okay, then you can exit from the workbench. Exit from the workbench in the sense you can exit from the 2D sketching environment to 3D modeling environment. Okay, then by using those 3D modeling features, we can convert the 2D sketch into a 3D model. All right. Now, if I want to create this body, okay. So what I will do is firstly, I'll be creating the outer body over here. Okay. So for that, I'll consider 3-point rectangle. Oh, sorry, center point rectangle like this. If for now, I will hide the planes for better understanding and better viewing purpose. Okay, so these are the default Y and vertical and horizontal axes. Okay. Now, once after creating the shape, you need to define the shape with the dimensions provided, which is 135 over here. and then vertically it is 64. Okay. Now you can able to provide this. Uh, yeah, you can able to provide this radius over here. The radiuses are provided. Okay. So you can provide that radius. So what I will do is I'll create a center point. Okay. No need of this one. You can able to use this one. I can simply create a 3-point arc over here. And then I can provide the dimension. This is R60. Okay, so over here they have provided R60. Okay, and then this is four places R15. That means this one is R60, this one is also 60, this one is also 60. I'm assuming because they haven't provided me this fillet. So I'm assuming all these arcs as R60. Okay, so I'll provide this one also, same R60. Okay, and one more R60 I'll provide, connecting these two R60. Now what I'll do, I'll make the tangent relation between all these arcs. So for that, I'll select these two arcs, go to constraint definition, make it tangent. Okay, little bit outside, no worries. And these two make it tangent. One second. Make it coincident first, then you can able to provide that fillet over there. R60, then this arc and this arc tangent. Now basically this is a straight line and it is connecting with an arc. So this shouldn't be an arc over here. Okay, it should be a straight line over here and also straight line over here because 3R60 arcs cannot be made tangent. This is tangent right now. Similarly, these two are tangent. Okay. And at the corner, we have R15 fillet. So you can provide R15 at the corner. 15. Okay. Now I can delete this part and same thing, I'll mirror it onto the other side. Okay. Mirror entity, select the arc and then mirror entity, use the center vertical right point. Okay. And then remove the things which are not required. This. Okay. So this is not tangent. as well as this one, and make coincident also as well. Now you can remove this part like this. Okay. Now over here, what I will do is I'll fix this part exactly at the center. So make it coincident, something like this. Okay. And then, so basically this 64 is from here to here, right? So that means I'm guessing this length was not provided. Okay. So what I'll do over here is I'll select the center point of this one and then make mirror onto other side. Select this, select this, select this, and this, and mirror onto this side. Okay. Now remove this one, which is not required. Right. So this length was not provided from this top to this top. So what I can do is I'll again consider 135 as a reference. 135. Now, if you consider it as a 135, then it will be okay. What I can do is I can first create this circle. At this point, and then define this circle as 15. Yep. So it will be on to the other side also. This one with respect to this one. Okay. Now I can able to provide the dimension from here to here as 64. So this is having the relation R15, and again I'll try to mirror it, or else I'll give the separately because it is taking the relation. Okay. Now let's give it as R15 again. Okay, this both are symmetric, so that's why 64. Okay. Now it can be a little bit like this. So this one is exactly coincident with respect to this point, coincident over here. Now I can able to select these two circles and then mirror entity onto the other side. Yeah. We can later also do that one, but yeah, no problem. Now, once this is done, you can just simply exit from the workbench. You can see over here, your design history is saved. You can just simply exit from the workbench. This is having 10 width. Okay. Right. After exiting workbench, you can able to make it isometric view over here. Acha, this was made on the front plane, right? So I can able to edit the plane also as well. Change this sketch support. So instead of YZ, I'll I'll select XY plane so that it will be on the top plane. Okay, and it looks like this. Now, once after we created this one, we can just simply pad it. Okay, that means convert into a 3D model. Yeah, by selecting this one. And what is the width? Over here it is 10 mm. Yeah, you can define it as a 10 mm. Okay. Now you can see your history is automatically saving over here. Now, if you want to edit the first sketch, you can just simply double click on the sketch one, then you can go into the sketch. Okay. Now the next one will be the top surface over here. Okay. So for that, uh, yeah, we have an ID of 75 and then OD of 80. Okay. So firstly, what I will do is again, I'll consider this surface, go to sketch. Okay. Create this circle, create two circles and define the dimension over here as 75 and then this one as 80. Yep. Once that is done, you can just simply exit from the workbench. And now from there to there, we have 25 because bottom it is 10 and then totally it is 25. Okay. So again, I'll be using pad and select this sketch and define it as 25. Okay. And slowly, gradually like this, we need to develop our model. Okay. There are multiple ways to create this sketch also as well. Okay. And then there is a cut at the bottom. So again, I'll consider this face sketch over here. Okay. Over here, I'll project this onto the new sketch. Okay. Then exit from the sketch. Then what I'll do, I'll create a pocket. Okay. Completely like this. Okay. And that not we have few more things. At the bottom, you can see there's this 80 and then there is this draft angle at the bottom. Okay. So that draft also you can provide or you can able to directly chamfer it over there. Okay. Uh, So you can able to use the chamfer over here and provide 90, this one. Instead of chamfer, I'll be using project this. Okay. What I will do is over here, I'll use draft pocket. Okay, draft fillet pocket. Where over here you can see I'll be providing 90 degrees depth. How much depth they have given? 7 mm of depth. Yeah, and then okay. So I'll be doing one more thing. Instead of this one, I delete this. So I'll unhide these planes. Okay, I'll consider this plane sketch. Okay, and I'll create the profile as per my requirement. So what is my requirement? I can able to create my profile in this way so that I can able to use my revolve feature. Okay. So now this is having 90 degrees, right? So this one is having 90 degrees over here. Sorry, this will be 45. And then, okay, and then we have 80 on the top. Okay. And we have 7 mm of depth over here. Okay. And it's a closed profile. So I'll just exit from the sketch. Okay. Now I'll hide the planes. I'll be using shaft feature over here. Okay. Instead of shaft, I'll be using groove because I want to make a groove. Okay. A profile will be this profile and axis of revolution will be this one. Okay. Click on OK. You can see we got that cut over there. Okay. And also in between you have one more profile. Okay. Which is a groove typically with some 12.35 mm. All right. So that also will be creating. Again, we'll consider a plane. Okay, not this plane. YZ plane. Okay, let's see how the view is look and go to normal view. So over here, first let's create the profile. Then you can able to do the sketching, dimensioning. Okay, so it looks for me like a slot. Okay, so I don't need a complete slot, but half slot I need. So I have a slot option over here, right? So this is having some radius, which is 12 point. 12.35. Yeah, this 12.35 radius. Yeah. So we'll do one thing. Instead of slot, just create a rectangle. Okay. And then create that 3-point arc from here, and here. Yeah, which is 12.35. 12.35. Yeah. Now, now we can remove this unwanted part, this one, and let's define the dimension. So the dimension over here from this point to this point, it is 75. All right. So from this, from the edge, right, from the edge to edge, 75 by 2. All right. And its position, where it is positioning vertically means from the top, okay, we have 5 mm. Right. So from the top to this length, we have 5 mm. Okay. And the total width is 15 mm. Okay. So total width is 15 mm. Okay, so over here we need to make these two vertical. You can just create a line over here, construction line, and then make it vertical. So this outer circle is, I guess I have created it wrong. It should be some 92. Okay, so yeah, 92. And the groove at the bottom should be, yeah, 75 is okay. The ID is correct only, 75. Yeah. The ODA should be 92, right? So this one. Now over here in this sketch, I think is done. So what I can do is simply I can exit from my sketch. This is not required. I can able to use groove. Okay. Sketch will be this one. Axis of revolution will be this one. Click on OK. Okay. Now you can see it is created. The groove is created. Now over here you can able to change the color also as well if you want. Okay. So for that, uh, sorry. Yeah, it is here. Jewel to material. Yeah. Properties, graphics. Over here, you can apply any color in the product. 1 second, this is not. Colors and edge faces. Colorless, huh? Colored from outlines. Hmm. No, color management. No, it is not coming basically because, okay, what I'll do is I'll apply the material or else material. Yeah. So over here, I can go for paint. Okay, DS light blue. You can just apply it onto this. Apply material. Click on OK. Then you can change it to this one. Uh, Material. Click on OK. Okay. So you can able to apply the different kind of materials also as well, or same color if you want to apply, you need to search for that. Basically, that's it. Okay. Except that color, we have all other. Okay, no problem. We can able to apply any other color over here, except for this one. Hmm, that's okay. Okay, and then just change it to shaded or visible. No smooth edges. Also verticals. That's it. Yeah, you can able to provide any other color also as well. And then if you want to see the sectioning view, it is also possible. So for that, you have this sectioning view toolbar over here. So according to your requirement, you can able to select whatever the size you want to section. Sorry, whatever the side you want to section. For example, this side, if I want to section, I can able to section this side and go to normal view to see this one. Okay, you can see the section view and also this section view in the figure. You can see everything is matching over here. All right.